Hello guys, this is the update 2 on our lift mockup, which is for our sensors course, and this is where we have reached at till now. This is sort of like the second part, the actuation. As I said last time, the next update would be on the actuator, and it took a while. I had to get the pulleys and the motor and all of that, but now all of that is ready, and I have a sort of test circuit ready again. So you can see again the Uno, same as before, except right now I haven't connected that DF player setup. We'll integrate that later. Of course, the final setup is gonna have all of it together, but as of now, it's just the motor basically. And what we are using is the NEMA 17 stepper motor, and that basically needs a driver, right? You can't directly drive it from the microcontroller. It's a motor after all, and it takes a significant amount of current, even 1 amps or 1.5 amps at peak, depending on your load. Of course, our load is not much. It's a belt and pulley drive system with one pulley below and one pulley on top. So first I'll just show you the circuit part of it. It's nothing, it's just the driver. It's the A4988 driver. It's a very common driver which is used for this stepper motor. And as you can see, it has the 100 microfarad capacitor. It needs it because it suddenly draws a lot of current, so even your power supply may not be able to handle that, so you need that capacitor there. And along with that, basically you just need to connect the VDD and ground of your Arduino, which is to sort of level shift the signals which you give. You're going to give the step and the direction signal to the driver, and you need the 5 volt reference logic for that, and you need to common both of the grounds. So that's basically what the driver is, and the output of the driver basically goes to your four wires which come from your stepper. And these are the four wires from the stepper. I've just connected them with this sort of adapter like thingy, and I've made a sort of cardboard setup for the lift. The final one will of course be sunboard or foam board. It looks better, but for now it's this cardboard thing, and it still looks pretty good. Just show it to you. So you can see basically this is the entire lift sort of structure, and yeah, that's the top and this is the bottom. And if you just look behind here, that's our NEMA 17, and there's the pulley. It's a GT2 pulley, 36 teeth, and this is basically our timing belt, again GT2 belt. And on top again you have the second pulley, so it sort of forms this belt pulley driven system. This is called the idler pulley, basically because you don't really give it any power. This one is physically attached to the motor there, so you give that power. And just to make sure it doesn't shake, these are two crocodile cables which are sort of clamping it on both sides, and the belt is there. And our passenger is basically this duck. Yeah, that's the passenger, and this is our carriage of sorts. It's stuck to the belt to sort of simulate the actual lift structure. So, and I've written these floors here. You can see this is the ground floor, first, second, and third floor. So it's a 4 floor lift, and currently it's at ground floor. When this basically aligns with this, it's at ground floor, and that's the entire mock-up setup of sorts. So just a small Arduino code written for this. This is still again in the testing stage, but what we're going to be doing is I'm just going to be giving a 2 letter code here, as you can see from this line. Basically we're going to give either up followed by how many floors you want to go up or down. So basically U1 would translate to going up by 1 floor, U2 by 2 floors, D1 by 1 floor, and so on. So U or D basically. So yeah, that's basically the code, and it physically moves it, the motor, depending on how many steps you give. So yeah, that's the whole code, and I'll just connect the power supply and let's see how it's moving. So yeah, now the power supply is connected, and what I'll do is I'll give a command of, let's say, U1 over here in the serial monitor. So I'm giving U1 here, and it will just say going up by 1 floor, and you can physically see it moving. So let me just click that. Yes, and you can see it's went sort of reached the first floor, and it said here going up by 1 floor. So now let's try going directly to the third floor, right? So let's give a U2 command. So U2. Yeah, it reached the second floor, and it's sort of exactly aligning, and that's exactly why we're using a stepper. It's a very precise. You can even micro step in this, so it's very precise depending on the number of steps and the pulley teeth you have. You can exactly calculate how much linear distance you want to move. So I've basically uniformly spaced these floors. That's why I'm able to sort of digitally move how many ever floors I want. And that's exactly the point. That's what we want. So now let's go down directly by 3 floors, which is D3, and we'll directly reach the ground floors. Yeah, and that's it. So you could clearly see it goes exactly how we want, and we can even control the speed of how fast you want it to move. Roughly, I've set it to like 5 millisecond delay between each step. That's why it's taking a decent amount of time, because we want to see it moving, right? That's why I've made it a little bit slow. And yeah, now the next, this is the update as of now. To this same mockup, I'll basically add the two sensors, which is the Hall effect sensor. I have it here in my hand, which will basically sort of act like a limit switch. We're going to be putting them on the extreme ends, which is the top here and the ground here. So let's say right now if I had entered D4, by programming it would try to go, but then again your carriage would basically hit this pulley here and all sorts of things can happen, right? So we need to prevent that. So even if the command is to go more than 3 floors, you stop it at 3. So it sort of generates an interrupt and you physically stop it. And how we're going to be doing that is, since this is a Hall effect sensor, it detects a magnetic field. You have these small neodymium magnets, right? So you can stick one right here. That's what we're going to do. And yeah, that's going to basically detect when the carriage has reached the limits. And next, that is going to be the second thing. And of course we're going to integrate this with the earlier update, which was the DF player. So now we can actually hear the announcements, see it on the LCD. We don't really have to see it on the serial monitor here. So that's going to be the next update, which is going to be combined all of that. So yeah, let's just stay tuned for the next update. It's sort of reaching, this project is reaching its completion. And yeah, good progress going on. So yeah, thank you.